Hello, hello friends. Let us solve some examples of linear programming. So the very first is objective function of a linear programming problem is, it can be asked like this, and there are four options, but the answer is the objective function of a linear programming problem is a function to be optimized. So the answer is this way. Okay. Second, let x and y be optimal solution of a linear programming problem, then so you are having some options here, but there is one concept here. It says like this, then z equal to lambda x plus 1 minus lambda y 0 less than or equal to lambda less than or equal to 1 gives an optimal solution. So there will be four options. You have to write this as the answer. Next, the optimal value of the objective function is attained at the points blank. So here you are having some options, and you have to select the correct option, and the correct option here is given by corner points of the feasible region. So that will be the correct option. Next, the corner points of the feasible region determined by the system of linear constraints are 0 10 5 5 15 15 0 20. Let z equal to px plus qy, where pq positive. The question is conditions on P and Q so that the maximum of Z occurs at both points 15 15 and 0 20 is blank, and here options are this P equal to Q, then P equal to 2Q, then Q equal to 2P, and Q equal to 3P. Now see, you are having the Z as Px plus Qi. So Z equal to Px plus Qy. Now you are given the maximum of Z occurs at both 15 15 and 0 20. So at 15 15 the value of Z equal to 15P plus 15Q, and at 0 20 Z equal to 0 plus 20Q, so 20Q. Now maximum occurs at both these points, so this right side, so this value must be same, so that means 15, so maximum occurs at both points. So therefore this and this one are equal, so 15P plus 15Q equal to 20Q, and therefore 15P equal to 20Q minus 15Q, so 5Q, and therefore 3P equal to Q, so Q equal to 3P. So that is the answer. So D is the answer. Okay, next. So you are given some statement. There are 4 statements you are given, and you are asked to find which is the correct statement. So there is one concept, and that you need to remember, and that is nothing but if a linear programming problem has two optimal solutions, then it has infinitely many solutions. So basically, if a linear programming problem is having two solutions, two optimal solutions, say one is at here, another is at here, say at B, then any point, you take any point on this line AB will be a solution, and therefore you can say that there are infinitely many solutions. So if a solution, if there are two solutions, then there are infinitely many solutions. Next, in solving the linear programming problem, this one, minimize z equal to 6x plus 10y, z equal to 6x plus 10y, subject to x greater than or equal to 6, y greater than or equal to 2, 2x plus y greater than or equal to 10, x greater than or equal to 0, y greater than or equal to 0. The question is redundant conditions, or you can say redundant constraints, are blank. Now what does it mean? It means that which are the constraints not required, okay, or if you can remove that constraint, then the problem will again remain same. Here the options are x greater than or equal to 6, y greater than or equal to 2. Then another option B, 2x plus y greater than or equal to 10, x greater than or equal to 0, y greater than or equal to 0. C, x greater than or equal to 6. And the D option is x greater than or equal to 6, y greater than or equal to 0. Now here you need to carefully observe the problem, that which are the constraints, that, and you see the options also, that which are the constraints that if you remove, then also there won't be any problem. So here after carefully looking, you can see that if our say x is greater than or equal to 6, y is greater than or equal to 2, these two, if you keep here, then automatically x is greater than or equal to 0 and y is greater than or equal to 0. So that means if I keep x greater than or equal to 6, y greater than or equal to 2, then I don't require x greater than or equal to 0, y greater than or equal to 0. That is the first thing. So this must be redundant. But now one more thing. If x is greater than or equal to 6, y is greater than or equal to 2. So if you are having any value of x which is 6 or greater than or equal to 6, value of y which is greater than or equal to 2 or which is 2 or greater than or equal to 2, then automatically 2x plus y greater than or equal to 10. What does it mean? It means that if you are having x greater than or equal to 6, y greater than or equal to 2, you don't require 2x plus y greater than or equal to 10. That means the condition, this one, 2x plus y greater than or equal to 10, x greater than or equal to 0, y greater than or equal to 0, do not required. These three constraint not required if you keep x greater than or equal to 6, y greater than or equal to 2. So the redundant constraint is are 2x plus y greater than or equal to 6, x greater than or equal to 0, y greater than or equal to 0. So B is the option. Okay. So here that means if x greater than or equal to 6, y greater than or equal to 2, then that is automatic that x greater than or equal to 0, y greater than or equal to 0, and 2x plus y greater than or equal to 10. So these are the redundant. Okay, fine. Let us take one more. One more. Here you are given like this: a feasible solution to a linear programming problem is blank. Now here you are given some options, but then you need to select the correct one. So I just write down the theoretical correct one, so that out of that 4 options you need to write this one. So a feasible solution to a linear programming problem is always satisfying or satisfy feasible solution to a linear programming problem always satisfy the problem's constraints simultaneously. That means all the constraints should satisfied, okay, at the same time. So that is the thing. Next, for the linear programming problem, maximize z equal to x plus 4y subject to 3x plus 6y less than or equal to 6, 4x plus 8y greater than or equal to 16, and x greater than or equal to 0, y greater than or equal to 0. The options are, so value of this maximize means value of maximum z 4, 8, then feasible region unbounded, and fourth has no feasible region. Now see here that you are having two constraints. One is 3x plus 6y less than or equal to 6. So this 3x plus 6y less than or equal to 6, can we write this as x plus 2y less than or equal to 2. So we have just divided by 3. Then 4x plus 8y greater than or equal to 16. So can we write this as, so we divide by 4, x plus 2y which is greater than or equal to 4. So now it is easy to see that does there any feasible region exist when x plus 2y greater than or equal to 4 and x plus 2y less than or equal to 2. So that kind of region does not exist. So the answer is this problem has no feasible region. So the answer is D. Okay, next. For the linear programming problem, maximize z equal to 2x plus 3y, the corner points are corner points of bounded region are, say, A 3 3, B 23, C 2010, then D 1812, and E 1212. The question is maximum value of Z is blank. So the options are here 72, 80, 82 and 70. Now here what you need to do is, here you are having a vertex, vertices you are given corner points and the value of Z. So at each point you find out the value of Z. Say A 3 3, so x is 3, y is also 3, and you can find, you will get 15 here. So then 23, so you will get 49. Then 2010, you will get 70. Then 1812, x is 18, y is 12, you will get 72, and E 1212, and you put 12 and 12, x is 12, y is 12, you will get 60. And here you can see that this 72 is the maximum value. Okay, this 72 is the maximum value. So this is a maximum value. So answer is 72. A option is the answer. Okay, next let us see. So similarly, if there is a question of minimize, then the minimum value is your answer. Okay. Okay, let us see one more. So I am not writing an example of minimize, that you can even now understand, easy to write. So here question is solution of the following LP problem is blank. The problem is minimize z equal to minus 3x plus 2y subject to 0 less than or equal to x less than or equal to 4, 1 less than or equal to y less than or equal to 6, and x plus y less than or equal to 5 is blank. So the options are minus 10, 0, 2, 10. Now this is not difficult, you don't require even a graph paper also, because you can easily draw the graph here, like here you are having x is 0 to 4, x is 0 to 4, that means x is a y axis, x equal to 0 is a y axis. One more thing is x plus y less than or equal to 5. So say suppose this is x plus y less than or equal to 5. So x plus y less than or equal to 5 is this much, and so this must be a point 0, 5 and 5, 0. Okay, so this is 5, this is also a 5. Then x is 0, so this one is there. X is 4, x is 4 somewhere here, so 5 is there. So this is x equal to 4, so this line is x equal to 4. So here this line is x equal to 4, this is x plus y equal to 1. When you take x equal to 4, y equal to x plus y equal to 5, this is. So when x equal to 4, y equal to 1, so this point is 4, 1. Y is 1 to 6, so this 1 is there, so this is y equal to 1 and y equal to 6, so here already 5, so 6 is here somewhere, so we don't require also. So what are the corner points? The corner points are here, that means this is 0, 1, then this one is here, that is 4, 1, and here that is 0, 5. So there are only 3 corner points, and here you are having so corner points are and z equal to minus 3x plus 2y, and corner points are 0, 1, then 4, 1 and 0, 5. So if you put this value here 0 and 1, so this is 2, 4 and 1 minus 12 plus 2, so this is minus 10, 0 and 5, so you will be having 10. So this one is the minimum value, this minus 10 is the minimum value. So minimum value is minus 10, this is minimum value. So the answer is minus 10. So this minus 10 is the answer. Okay. Okay, let us take one more. the corner points of the feasible region determined by the system of linear constraint are 0, 10, 5, 5, 15, 15, 0, 20. Suppose z equal to px plus 3y, where p greater than 0. If the maximum of z occurs at both the points 15, 15 and 0, 20, then P is blank. So options are 4, 5, 1 and 2. So this kind of example we did. Z equal to px plus 3y and maximum of z occurs at both 15, 15 and 0, 20. Same example but little differently asked. So at 15, 15 z equal to 15p plus 45 and at 0, 20 z equal to 60. Okay, and these two are same. So 15p plus 45 equal to 60 and therefore 15p equal to 15 and therefore p equal to 1. So this C is the option. Okay, next let us see how many points with integer coordinates lie in the feasible region defined by 3x plus 4y less than or equal to 12, x greater than or equal to 0, y greater than or equal to 1. The options are 7, 6, 5, 8. Now we need to very quickly draw this region 3x plus 4y less than or equal to 12, x greater than or equal to 0, y greater than or equal to 1. So three x plus 4y less than or equal to 12. So we need to draw that line. 3x plus 4y say equal to 12. So if I take x equal to 0, y equal to 3, and y equal to 0, x equal to 4. So this is say 1, 2, 3. So this is 3, 1, 2, 3, 4. So here you are having like this, the line 3x plus 4y equal to 12. Then x greater than or equal to 0 and y greater than or equal to 1. So we need y equal to 1 is this kind of line. So this is a line y equal to 1. So here the point is, okay, so this point is what? Y is 1. So 12 minus 4, 8, and x is equal to 8 by 3. So this is 8 by 3 and 1, 2 point something. Okay, I think we need to draw properly, because x is 8 by 3, so it's not complete 3, it's less than 3. So here 1, 2, 3, so it will have some mistake also. So let us take care of drawing this graph, and okay, so better we draw properly here. So this is say 3, this is say 4, and x is equal to 1, somewhere here. So this point is, this line is 3x plus 4y equal to 12, and if I take y equal to 1, then 3x equal to 12 minus 4. So x equal to 8 by 3, 2 point something. Okay, so this is x is equal to 8 by 3, not completely means less than 3. So somewhere 3 is somewhere here. Okay, so that we need to take care. So here it is say 0, 1, say 2, like this. Otherwise there will be a mistake. Okay, so what are the integer points? Let us see now. So this is a 1 point, then there will be one another point here, there will be one another point here, because 2 here, 1 here. Now this is not integer point. Okay, this one is 3, this one is 1, so this one is also 2. So there is also one more point here, integer point, then this one is also there, and now in between these two there is one point here somewhere. So now there won't be any other integer point. Okay, so we are having total how many integer points? So this is 1, 2, 3, 4, 5 and 6. So there are 6 integer points in the feasible region. So answer is this B. Okay. So you are having this kind of examples, and then you can solve the examples, and it's not difficult in fact. So let us take one more example. Which of the following is not a vertex of the feasible region bounded by the constraints two x plus 3y less than or equal to 6, 5x plus 3y less than or equal to 15, x greater than or equal to 0, y greater than or equal to 0. Options are 0 to 0 0, 3 0, 0 5. So the question is which is not a vertex. Okay, that means which point does not satisfy all constraints simultaneously, that we need to see. So we need easily check one by one. Suppose if I check for A, and that is 0 2. So if I put that part in first, this one 2x plus 3y less than or equal to 6 is satisfied. 2 into 0 2, sorry 2 into 0 0 plus 3 into 2 6, 6 less than or equal to 6, yes. Then this satisfied. 3 into 2 6, 6 less than or equal to 15, yes, and this already satisfied. Okay, so this is a vertex, this is a vertex of a feasible region. Similarly you have to check B, so you have to check B, so that is also there. Similarly you have to check C, this 3, x is 3 and y is 0, so 3 to the 6 less than or equal to 6, yes. 3 5 is 15 less than or 15, yes, and the x greater than or equal to 0, y greater than or equal to 0. So only remain is D. D you will see it is not satisfied for some. X is 0, y is 5, so 5 3 is 15, 15 less than or equal to 6, so that is no.